All right, so let's talk Lewis structures. All right, how's that sound? Uh, so we had talked about this, and you can follow these rules, and these rules work all the time. But I wanted to just sort of logically walk you through it so that you can feel more comfortable doing it yourself. So what we have here is not what I need. All right, if we're going to do water, water has hydrogen, two hydrogens, and an oxygen. Now, hydrogen would make a bad central atom. Hydrogen is listed first, which tends to be the central atom, but since hydrogen can only make one bond, it's an awful central atom. You can only make one bond off of it. So when you see a hydrogen in front, you're going to use the second atom as a central atom. And that will occasionally happen when hydrogen is in front to indicate that something is an acid. If, however, there's not hydrogen in front, then we'll just use the first atom as a central atom. So in this case, oxygen is going to be the central atom. And we want to add up the valence electrons that everything's bringing along. So oxygen's bringing 6 valence electrons. Hydrogen's bringing 1, and there's 2 of them. So that's a total of 2 and 6 equals 8 valence electrons. So what we're going to do then is we're going to start with the oxygen, and we're going to try to draw 2 hydrogen bonds off of that. So here that is. So here's oxygen, and there's 2 hydrogens coming off of that. Now, if you'll notice, each bond has 2 electrons, one from the oxygen and one from the hydrogen. So in this case, right, so the hydrogen has 1. So the total of 2 electrons per bond means we have 1, 2, 3, 4 electrons already used. So 8 minus 4 means we have 4 electrons left. Now we got to make sure everything has a complete octet. Hydrogen, trying to be like helium, only needs 2 electrons to have a complete noble gas configuration. So hydrogen is set by sharing the electrons with oxygen. Oxygen, on the other hand, still needs, it has 1, 2, 3, 4, so it still needs 4 more. So we're going to use those last 4 electrons to fill the outer shell and end the valence of oxygen. So oxygen now has 1, 2, 3, 4, 5, 6, 7, 8. Hydrogen has the 2, and hydrogen has the 2, so we're done. So this is the Lewis structure for water. Now, if we were to look at it from another perspective, here's oxygen, and oxygen had its 6 valence electrons, like this, and then here comes hydrogen, and hydrogen has its 1 valence electron twice. And if you look there, then what we have is a situation where, let's make that green, I guess. This is a bond, and this is a bond. And that gives you the same sort of structure. This is the same structure as that. All right, so let's try NCl3. Nitrogen has 5 valence electrons. Chlorine has 7 valence electrons, and there's 3 of them. So that's 21 plus 5 is a total of 26 valence electrons. Nitrogen is listed first, so we're going to make that the central atom. And we're going to bond that to the 3 chlorines. So let's, I should have made chlorine green, but whatever, 20/20 hindsight. There's 1 chlorine, there's 2 chlorines, and there's 3 chlorines. So each of these bonds, remember, each of these bonds here requires 2 electrons. So since we've had a total of 26 electrons, we've now used 2, 4, 6 electrons to bond everything to nitrogen, which is our central atom. So 26 minus 6 means we have 20 electrons left. So the next thing we're going to do is complete the octets for the outer electrons. And the outer electron here is chlorine. So each chlorine, because it has 2 in the bond, will need 6. So there's 6 on that one. Here's 6 on that one. And here's 6 on this one. So now we have, we've used 18 more of these 20 electrons. 20 minus 8 means we have 2 electrons left. We have completed the octet on all the outer atoms, and now we can deal with nitrogen. Nitrogen only has 2, 4, 6 electrons on it. It needs a total of 8, so we're going to give it 8 by putting those last 2 electrons on nitrogen. And then that is the Lewis structure for NCl3. And to look at that another way, then you could have the 5 electrons on nitrogen, and then we throw in the 7 electrons for chlorine. Right? And this is what we'd get. The same Lewis structure as we got with the accounting method. And then if you looky there, you have, I'll use red this time, 1 bond here, 1 bond here, and 1 bond there. So it looks just like what we did with the accounting method, but that helps you visualize maybe a little better where all the electrons are coming from. All right, so moving on to carbon dioxide. Carbon is the central atom. It's the one listed first. There's 4 valence electrons on carbon, and oxygen has 6 valence electrons. There's 2 of them. 6 times 2 is 12, 12 plus 4, so we have 16 total valence electrons. The central atom is going to be carbon, and we're going to single bond that carbon to 2 oxygens. I'll do that in red because that's what we learned in grad school. All right, so each of these bonds here have 2 electrons in them, right? 1 from carbon and 1 from oxygen. So 16 minus 4 means there's 12 electrons left. With those 12 electrons, we're going to try to complete the octets for the oxygen. So 1, 2, 3, 4, 5, 6. That completes that one. 1, 2, 3, 4, 5, 6. So we've used all 12, and now we're down to 0. Now the problem is, while oxygen's octet is complete, 2 from the bond and 6 from the lone pair, for a total of 8. 2 from the bond and 6 from the lone pair for a total of 8. Carbon, however, just has 2 and 4, and it wants 8. So the way we're going to complete this is we're going to take 2 electrons from one oxygen and turn that into a bond. And we're going to take 2 bonds from the other oxygen and turn that into a bond. And when we're done, we're going to have carbon double bonded to 2 oxygens. So that's going to look like this. And then, just for fun, we'll keep the oxygen in red. And then each oxygen will have 4 electrons as lone pair, and then it has the electrons from the bonds. So this oxygen now has 2, 4, 6, 8. This oxygen has 2, 4, 6, 8, and this carbon has 2, 4, 6, 8. Everybody has 8. That's good to go. Now to do this the other way, if you did oxygen has 6, 4, 5, 6, and then the other oxygen has 6. 1, 2, 3, 4, 5, 6, and then we put that carbon in the middle. Put that carbon in the middle, and it has 4, 2, 3, 4, and then the bonding will occur. This in green. So there's a bond here, and there's a bond here, and there's a bond here, and there's a bond there. So that can then be redrawn as the same as that, basically. All right, so either of these ways are going to work. The problem with doing it this way, this sort of, besides the fact that sometimes it comes out very messy, like it looks right there, that's pretty messy, that's very nice, is you want, when you use charges, when charges are involved, that gets a lot harder to deal with. So if we look at nitrate, NO3 minus 1, so this is NO3 minus 1, all right, that's a 1. So there's 5 valence electrons on the nitrogen, there's 6 valence electrons on each oxygen, there's 3 for a total of 18. And then there's 1 electron in the charge, that minus 1. So that means we add 1 electron. So 18 plus 5 is 23, plus 1 is 24 total electrons. So we're starting with 24 electrons. Nitrogen is our central atom, so we're going to put nitrogen in the middle. And we're going to want to bond 3 oxygens here. So you see 3 oxygens being bonded. Each bond is 2 electrons. So that's 2, 4, 6. So of our 24 electrons, we've now used 6 for bonds. And that leaves us with 18. And with those 18, we want to complete the octets for the oxygen. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4, 5, 6. 6 times 3 is 18. So we now have 0 electrons left. Our oxygens all have complete octets, but our nitrogen only has 2, 4, 6 electrons on it right now. So we need to get more electrons on the nitrogen, but we don't have any more. So we're going to double bond to finish that octet. Now we could use any of these lone pair to do it. I guess it looks like here I use these two here to double bond, but you could have used these or those or these or those, right? Any of these could double bond. They're all oxygen, so they're all the same. So that oxygen double bonds, and we have now 8 electrons around nitrogen, 8 around each oxygen, 8 around this oxygen, and 1, 2, 3, 4, 5, 6, 7, 8 around that oxygen. This gets a little uglier if you want to do it with the possession method, because the reality is electrons aren't really being possessed anymore when they get into this bonding situation. It's sort of like when you put your money in the bank. The money you get back when you take money out of the bank isn't the exact same money that you put in. So if you put a $20 bill in and you put your name on it, the next time you go to the bank and ask for $20, it's not going to be that one with the name on it. It's going to be a different one. And so that's true with these electrons. These electrons go to where they're needed for this bonding to occur. And to really keep track of this would be difficult. Now, it does work when there's no charge. It does actually work pretty well. And if you do this, this will get you through pretty good through this unit. But I really want to teach this charge method because there is something you will deal with if you ever do move on with chemistry. This is a chemistry course, so that's important to me. And that. All right, so I think that's Lewis structures. Yeah, and we'll hit this tomorrow. But anyway, as a sort of summary, carbon will typically make 4 bonds because it needs 4 more electrons to get an octet. Nitrogen has 5 valence electrons. It needs 3 more to get an octet, so therefore it tends to make 3 bonds. Oxygen has 6 valence electrons. It needs 2 more electrons to get an octet, so it tends to make 2 bonds. Halogens have 7 valence electrons. They need 1 more valence electron to get an octet, so they tend to make 1 bond. And hydrogen has 1 electron. It's trying to be like helium, so it needs 1 more electron, so it tends to make 1 bond. And you saw this when we were playing with the models, that all the hydrogens had 1 hole in it because they only make 1 bond. All the halogens had 1 hole in it because they only make 1 bond. All the oxygen had 2 holes in it because it tends to make 2 bonds. All the nitrogens had 3 holes in it because they tend to make 3 bonds. And all the carbons had 4 holes because they tend to make 4 bonds. All right, so hopefully that's helpful. And tomorrow we'll start talking about